Okay, for this next proof, looking at what we're trying to prove, we have line segment DC congruent to line segment AC. However, we're still in the chapter on triangle congruence, and if you look at the diagram, we do have two triangles. So that's what we need to do first. We need to prove these triangles congruent. And then the remaining parts, corresponding parts, for example, line segment DC and AC, are going to be congruent by CPCTC, which is that corresponding parts of congruent triangles are congruent. But again, in order to use that reason, we have to prove triangles are congruent first. So what I'm going to do is I'm going to take the given information, and I'm going to copy it down here under our two-column proof, and I'm going to mark it. Angle B is congruent to angle E. Angle congruent statement, angle congruent statement. Then I'm going to copy down line segment CE is congruent to line segment CB. That's given. And I'm going to mark that CE congruent to line segment CB. This is a side congruent statement. Now, from here, as I look at this, and I know looking at line segment DC and line segment AC and my segment congruence, the possible reasons, I know that I don't have anything here besides CPCTC, so I have to prove these triangles congruent. So to prove these triangles congruent, the triangles that we're discussing are triangle DCE congruent to triangle ACE. And as I look at this, some of the things that you might notice, or some of the things you might look for, is, I'm sorry, that shouldn't be CE, that should be ACB. But some of the things that you should look for is you should look at the vertices of your triangles here. D matches up with A, C matches up with C. Now when you see that, that doesn't necessarily mean the reflexive property. Unless it's the exact same angle, it's not going to be. However, it does have the same vertex, which in all likelihood, not always, but in all likelihood, would mean that these are possibly vertical angles. And that's one of those things that you have to be really familiar with your list for your reasons for angle and side congruency. You have to be able to recognize them in a diagram, because a lot of you probably saw this immediately. That these two vertical angles have to be congruent, obviously. These two angles are vertical, and therefore they are congruent. And you could say here that angle DCE is congruent to angle ACB. And that would be the definition of vertical angles. You can just say vertical angles. And what we have is we have another angle congruence statement. So here we have angle, we have a side, and we have an angle. Now, is that enough to prove the triangle's congruent? We would have to lean towards yes, but let's just double check and let's make sure of the order, because this order is not important. It's the order in the diagram, but looking at the diagram, we have angle, side angle, angle, side angle. So these two triangles are congruent by the angle, side angle congruence postulate. And if you go back to definition of triangle congruency, if triangles are congruent, that means all corresponding parts are congruent. When we first started, we had to prove all 6 of those. Now we only have to prove 3, but after proving those 3 and stating that triangles are congruent, by definition of congruent triangles, that means the remaining parts are also congruent. The remaining corresponding parts, for example, DC, side DC is corresponding to line AC, and if you look here in our congruent statement for triangles, you see DCAC. So those are corresponding sides, and because we proved these triangles are congruent by the reason CPCTC, so are those sides. Remember, CPCTC stands for all of the remaining corresponding parts in congruent triangles are congruent. You could also put definition of congruency there, and I would accept that as well. So that's how you complete this particular proof. Give these a look. Hopefully they help. If you have any other questions, send me another email, or make sure you ask tomorrow.